Imagine falling into a black hole. It sounds like a science fiction nightmare, right? You'd be pulled in with incredible force, stretched like spaghetti, and crushed into oblivion. While that's a dramatic picture, the reality of black holes is even stranger than we can imagine. But before we jump into the abyss, let's unravel the mysteries of these cosmic monsters. What exactly is a black hole? Think of the biggest star you can imagine. Now imagine that star collapsing under its own gravity, squeezing itself into an incredibly tiny space. That's the basic idea behind a black hole. It's a region in space where gravity is so strong that nothing, not even light, can escape its pull. Think of it like a cosmic vacuum cleaner sucking in everything that gets too close. Let's take a journey towards a black hole. As you get closer, you'd notice the first sign of trouble. Time itself starts to slow down. This is because the gravity of the black hole is so intense that it warps the fabric of space-time. You'd also see light bending around the black hole, creating a distorted halo. This is like looking through a funhouse mirror, but on a cosmic scale. Now let's talk about gravity. It's one of the most fundamental forces in the universe. And yet, it's also one of the most mysterious. Gravity is what keeps planets in orbit around stars, holds galaxies together, and gives structure to the entire cosmos. Without gravity, there would be no stars, no planets, and certainly no life as we know it. It's the invisible hand that shapes the universe on every scale, from the tiniest dust particles to the largest galaxy clusters. We all know gravity keeps us grounded on Earth. It's the reason why when you jump, you come back down, and why oceans stay wrapped around our planet instead of drifting off into space. Gravity is what gives us weight, and it's the force that makes life on Earth possible. Even the moon's gentle pull on our oceans creates the tides. But while Earth's gravity feels strong to us, it's actually quite weak compared to the gravity of some objects in the universe. But a black hole's gravity is on another level. Imagine a place where gravity is so intense not even light can escape its grasp. Black holes are formed when massive stars collapse under their own gravity, squeezing their mass into an incredibly small space. This creates a region where the gravitational pull is unimaginably strong, warping space and time itself. It's so strong that it creates an invisible boundary called the event horizon. The event horizon is the ultimate point of no return. Once anything, matter, light, or even information crosses this boundary, it can never escape. The event horizon marks the edge of the black hole, and beyond it, the laws of physics as we know them begin to break down. Once you cross the event horizon, there's no turning back. You're trapped forever. Even if you were in a spaceship with the most powerful engines imaginable, you wouldn't be able to escape. The gravity is simply too strong. In fact, as you approach the event horizon, time itself begins to slow down relative to the outside universe. To a distant observer, it would look like you were frozen in time, never quite crossing the boundary. But it gets even weirder. Black holes don't just trap matter and light, they also warp the very fabric of space around them. This warping creates strange visual effects like gravitational lensing, where the light from stars behind the black hole is bent and stretched, creating rings and arcs of light. It's as if the black hole is bending reality itself. As you fall closer to the center, the gravity pulling on your feet becomes much stronger than the gravity pulling on your head. This difference in gravitational pull is called a tidal force, and near a black hole, these forces become extreme. The closer you get, the more intense the stretching becomes until your body would be pulled apart atom by atom. This stretches you out like spaghetti, a process scientists call spaghettification. It's one of the strangest and most extreme effects of gravity in the universe. In the end, black holes remind us just how powerful and mysterious gravity can be, capable of shaping galaxies, warping time, and stretching matter to its limits. So, what happens after you cross the event horizon? This is a question that has fascinated scientists, philosophers, and science fiction writers for decades. The event horizon is often described as the ultimate boundary in the universe, a point beyond which nothing, not even light, can escape the gravitational pull of a black hole. Once you pass this invisible threshold, you are cut off from the rest of the universe forever. But what actually happens to you, or to anything, after crossing this point of no return? Honestly, nobody knows for sure. The laws of physics as we currently understand them simply can't describe what goes on inside a black hole. It's a region where our best theories, Einstein's general relativity and quantum mechanics, collide and break down. We can make educated guesses, but the truth is, the interior of a black hole is one of the most mysterious and least understood places in the cosmos. Our current understanding of physics just breaks down at the singularity, the point at the center of a black hole where all matter is thought to be crushed to an infinitely small, infinitely dense point. At the singularity, the known laws of space and time cease to function in any way we can comprehend. Gravity becomes so intense that it warps the very fabric of reality, and the concepts of space and time as we know them lose all meaning. The singularity is a place where the universe's rules are rewritten and we simply don't know what those new rules are. Some scientists believe that you might be transported to another universe, or that black holes could act as gateways or bridges, what we call wormholes, to distant parts of our own universe or even to entirely different realities. This idea has inspired countless works of science fiction, imagining black holes as cosmic portals to other worlds, other times, or other dimensions. While these ideas are exciting, they remain purely theoretical for now, with no experimental evidence to support them. Some theories even suggest that, under the right conditions, a black hole could allow for time travel. The extreme warping of space-time near a black hole could, in theory, create shortcuts through time itself. But again, these are just mathematical possibilities, not realities we've observed. The idea of traveling through time or space via a black hole is still firmly in the realm of speculation. But these are just theories. The truth is we have no way of observing what happens inside a black hole because no information can escape from beyond the event horizon. Everything that crosses that boundary is lost to us forever, making it impossible to test our ideas or gather data. All we can do is use mathematics, imagination, and indirect observations to try to piece together the puzzle. The truth is, the singularity still remains one of the biggest mysteries of the universe. It's a place where our understanding ends and the unknown begins, a cosmic riddle that challenges everything we think we know about reality. Until we develop new theories or technologies that can probe these extreme environments, the secrets of what lies beyond the event horizon will remain hidden, waiting for future generations to uncover. For now, the heart of a black hole is a reminder of how much there is still to learn about our universe. Not all black holes are created equal. Some are small, just a few times the mass of our sun. Others are supermassive giants, millions or even billions of times heavier than the sun. These behemoths lurk at the centers of galaxies, including our own Milky Way. The bigger the black hole, the stronger its gravity and the larger its event horizon. If nothing, not even light, can escape a black hole, how do we even know they exist? We can't see them directly, but we can observe their effects on their surroundings. For example, black holes pull in gas and dust, creating a swirling disk of superheated material that emits X-rays. By studying these X-rays, we can learn about the black hole's properties. Black holes may seem like destructive monsters, but they actually play a crucial role in the evolution of galaxies. They regulate star formation and influence the distribution of matter throughout the universe. By studying black holes, we can learn about the fundamental laws of physics and the origins of our universe. Black holes are one of the most fascinating and mysterious objects in the universe. These cosmic enigmas have captured the imagination of scientists, writers, and dreamers for generations. They are regions in space where gravity is so strong that nothing, not even light, can escape their grasp. The very idea of a place where the known laws of physics break down is both thrilling and terrifying. Black holes are born from the remnants of massive stars that have ended their life cycles in spectacular explosions called supernovae. What remains is a point of infinite density, known as a singularity, surrounded by an event horizon, the point of no return. They challenge our understanding of gravity, space, and time. When we look at black holes, we are forced to confront the limits of our knowledge. Einstein's theory of general relativity predicts their existence, but when we try to combine it with quantum mechanics, the science of the very small, things get complicated. The rules that govern the universe seem to break down at the edge of a black hole. Light bends, time slows, and space itself is warped in unimaginable ways. The phenomenon of gravitational lensing, where light from distant stars is bent around a black hole, allows us to glimpse their presence, even though we cannot see them directly. While we've learned a lot about black holes in recent years, many questions remain unanswered. Thanks to groundbreaking technology like the Event Horizon telescope, we have captured the first ever image of a black hole's shadow, confirming decades of theoretical predictions. Scientists and astronomers around the world are working tirelessly using powerful telescopes and advanced computer simulations to unlock the secrets hidden within these cosmic giants. Yet, despite all our progress, black holes remain shrouded in mystery. We still don't know what happens to information that falls into a black hole, or if there is a way to escape their immense pull. What happens inside a black hole? This is one of the greatest mysteries in all of science. The laws of physics as we know them cannot describe the conditions at the singularity. Some theories suggest that black holes could be gateways to other universes, or that they might contain wormholes, tunnels through space and time. Others propose that the information swallowed by a black hole is somehow preserved on its surface, encoded in subtle ways we have yet to fully understand. The truth is, no one knows for sure, and that uncertainty is what makes black holes so endlessly intriguing. Can we harness their energy? Black holes are among the most powerful engines in the universe. As matter spirals into a black hole, it heats up and emits enormous amounts of energy, sometimes producing jets of particles that travel at nearly the speed of light. Some scientists have speculated that, in the distant future, advanced civilizations might find a way to tap into this energy, using black holes as cosmic power plants. While this idea remains firmly in the realm of science fiction for now, it highlights just how much we have yet to learn about these extraordinary objects. These are questions that will continue to fascinate scientists and stargazers for generations to come. Every new discovery about black holes brings us closer to understanding the universe and our place within it. The quest to unravel their secrets drives innovation in technology, mathematics, and physics, inspiring new generations of researchers to look up at the stars and wonder what lies beyond the limits of our knowledge. So, the next time you look up at the night sky, remember that hidden among the stars are these enigmatic objects, silently shaping the cosmos around us. Black holes are not just distant curiosities. They are fundamental to the story of the universe. Their gravity sculpts galaxies, their mysteries challenge our minds, and their existence reminds us that there is still so much left to discover. The universe is vast, and its biggest mysteries are waiting for us to explore.